NASA unveiled pictures from a new space telescope capturing the deepest images of the universe anyone has ever seen.
James Webb Space Telescope zoomed in on the impossible galaxy. The real mystery deepened. Its spectrum, the light signature used to decode chemical composition, was unlike anything expected. Instead of the pristine hydrogen and helium from the early universe, the galaxy's light revealed the presence of carbon, oxygen, and even iron. These are elements forged in the fiery deaths of stars, supernovae that scatter heavy metals across space. But that process takes time. Generations of stars must live and die. Yet here was a galaxy, impossibly old for its time, already rich in metals. The only possible explanations were equally disturbing. Either the first stars formed, burned out, and exploded far faster than our models allow, or something else, something completely unknown, was creating elements without stars at all. Some researchers suggested that we may need to rethink how elements are made in the first place. Was there a primordial reaction in the early universe, some hyper-efficient process that forged complex chemistry in a flash? Or could this be evidence of an entirely different kind of universe evolution, one that doesn't follow the slow script we've come to accept? In the swirling mystery of light and time, the impossible galaxy refused to play by the rules. And with each spectrum analysis, it whispered a deeper truth, that everything we thought we knew about cosmic time might be wrong. Most early galaxies formed in busy neighborhoods, clusters teeming with protostars and swirling clouds of gas. But the galaxy that Webb found? It stood alone, surrounded by emptiness. It floated like a message in a bottle from a forgotten universe. This isolation was unsettling. It showed no signs of collisions or past galactic mergers, the usual markers of cosmic adolescence. It hadn't been shaped by its surroundings. It had seemingly evolved in a clean, untouched pocket of space. Why? Some scientists speculate that this clean zone may have been a unique pocket of space-time, an isolated bubble with conditions perfect for rapid evolution. Others suggest that the absence of chaos meant the galaxy had been shielded. Somehow, perhaps by exotic physics we've never encountered, its gravitational field was another anomaly. It didn't match what we'd expect from dark matter. Instead of being diffuse and messy, it was tightly concentrated, like a black hole's gravity smeared across the entire galaxy. Whatever this was, it wasn't an accident. Could this galaxy be part of a hidden architecture in the universe, one shaped by unknown forces or intelligent design? Could pockets of space evolve differently based on hidden variables? In the dark void where it was found, this galaxy wasn't just alone. It was protected, preserved, like a cosmic artifact buried where we'd least expect to find it. When the Webb telescope captured the galaxy's light, something in the color spectrum caught scientists off guard, instead of the deep redshift expected. From objects this far back in time, a natural result of the universe expanding, Webb detected ultraviolet and near-infrared waves fluctuating unpredictably. These weren't normal distortions. The colors seemed to oscillate. Light doesn't just do that. This wasn't caused by cosmic dust or motion. It wasn't a glitch in the instruments either. Multiple calibrations confirmed the anomaly. So what was going on? One theory suggested we might be seeing a quantum interference pattern magnified to galactic scales. A possibility so bizarre it sounds like science fiction, that the galaxy's light was interfering with itself, hinting at a strange entanglement between distant regions of spacetime. Another theory ventured into holographic territory. If the universe is a three-dimensional projection of information encoded on a distant two-dimensional surface, as some interpretations of string theory suggest, then what Webb saw might not be a physical object at all. It could be a cosmic rendering. Error, a pixel glitch in the fabric of reality itself. For a moment, astronomers stared at a galaxy that flickered like a ghost, there and not there. Light that told two different stories at once. And in that paradox, they glimpsed a terrifying possibility. What if reality is far less real than we think? As the data piled up, scientists realized something chilling. Webb may have seen more than a galaxy. It may have glimpsed the ghost of a universe before our own. Some physicists had long speculated that the Big Bang wasn't the beginning, but the reboot of a cosmic cycle. A universe born, expanded, died, and then began again. Webb's discovery breathed new life into that theory. The galaxy's rotation wasn't just stable, it was too stable. Its spin rate and internal structure hinted at preconfigured dynamics, as if shaped by forces with memory, echoes of a previous cosmic era. Then came the gravitational clues. The surrounding space warped more than it should have. The lensing effects, how light bends around massive objects, were stronger than its visible mass could explain. Dark matter couldn't fully account for it. Some theorized that this might be the gravitational footprint of ancient structures, residues from a universe that collapsed and passed on its scars to the next. Even more unsettling was the idea of cosmic memory, that remnants of previous universes might persist in the fabric of space-time, waiting to be uncovered. Was this galaxy truly young? Or was it ancient in a way we couldn't yet comprehend? Had it survived a previous cycle? Or was it born from the ashes of an older cosmos? If true, this discovery didn't just shift the timeline. It rewrote the origin story. The Big Bang may not be the beginning, just a breath between eternities. Webb sensors were designed for infrared imaging, but their precision revealed something no one expected: low-level energy signals in areas of space that should have been empty. These weren't glitches. Multiple readings across different deep space regions showed faint, structured patterns in the blank parts of the sky, regions devoid of galaxies, stars, or known radiation. The patterns were irregular but repeated. Faint, structured, almost intentional. At first, scientists thought they might be echoes of background radiation, the fading afterglow of the Big Bang. But they didn't match any known cosmic microwave background profiles. Then a chilling theory emerged. These were echoes of a false vacuum, energy left over from a universe that had not yet fully settled into its current physical state. The ion inflation theory. A false vacuum is a temporary state with higher energy than our universe's current stable configuration. If such a state still existed in certain pockets, it could explain these low-energy fluctuations. But here's where it gets eerie: that if these signals were real, they might be signs that our universe is still in transition, not finished forming, not truly stable. And if so, there remains a non-zero chance that it could suddenly shift again. A cosmic phase change. A second Big Bang. Not in the distant past, but sometime in the future. Or worse, tomorrow. As astronomers tried to make sense of the impossible galaxy and its strange companions, a haunting realization emerged. Maybe these weren't galaxies at all, at least not in the sense we understand. Some physicists began to speculate that the James Webb Space Telescope wasn't just observing distant objects, but actually looking into a cosmic mirror, a reflection of deeper laws, or even ourselves. According to a radical interpretation of the holographic principle, the universe is a three-dimensional illusion, a projection from a two-dimensional boundary, beyond space and time. What Webb saw, then, wasn't just ancient light. It was the code behind the curtain. Every twist in the spiral arms, every anomaly in elemental makeup, every flicker of UV radiation might not be evidence of something broken in our models, but evidence that our entire reality is encoded, governed by a substrate we've never touched. In this view, the impossible galaxy isn't an object. It's a leak, a piece of the universe's source code bleeding through the cosmic display. A cosmic artifact, not made of matter, but of mathematics. Even more unsettling? If Webb can see the code, maybe the code can see us back. Some theorists flirted with the idea that we had, by sheer accident, observed a cosmic feedback loop, a moment when the observer and the observed collapse into one. A moment when the act of looking reveals not what is out there, but what lies beneath it all. And if that's true, then the universe may be stranger than we ever imagined. It may not be a place. It may be a question. And now, we're part of the answer. That's all for today, but more brain-bending weirdness is coming. Hit that subscribe button.